Today we are going to talk about laws of chemical compounds. First one is law of conservation of mass. It states that matter can never be created or nor be destroyed. Okay? Matter can neither be created and nor be destroyed. So if I say that hydrogen reacts with oxygen and gives H2, it's 2 gram, 16 gram, and if I add them both, it's gonna be 18 grams. So the mass of reactants is equal to total mass of the product. That's what it states. The total mass of reactants is equal to total mass of the product. This is what we call as the law of conservation of mass. Next we have is law of definite proportion. Let's take an example. Imagine I have carbon dioxide, and if I decompose it, it's gonna be carbon plus oxygen. I have 12 grams of carbon, 32 grams of oxygen. So, what I exactly saw that whether this oxygen from any vehicle, from any industrial factory or any other place, the proportion of carbon dioxide, it's never gonna change. It doesn't matter that what the source is. It's about the proportion of these both gases. So what I mean is that proportion is same. So if the proportion is same, this law is known as law of definite proportion. All right, law of definite proportion. It's easy, isn't it? It's good. The next law we have is law of multiple proportion. In this law, what we actually do is let's understand by a simple example. If two elements combine, so it's obvious that when two elements combine, they form more than one compound, right? What to do is they form more than one compound, right? And then what happens is they form compounds. I'm going to write it in a short way. Let's say the compounds are hydrogen and oxygen. So when these two elements combine, they can make two different compounds, like they can make H2, or they can make this H2O2, right? These two products. So what can I actually say is I'm gonna remove this extra one. It's creating. Okay. So let's say the compounds that are made by these two elements is H2O and H2O2. Let's say the mass of this water is 18 grams and this one is 34 grams. So if I say the atomic mass, two atoms of hydrogen, one atom of oxygen contains 60 grams, then it's again 2 grams, and oxygen, there are two oxygen, so 16 into 2 is gonna be 32 grams. Even the masses are different in both the compounds, like in the first one it is 2 grams and 16 grams, and in the second compound it is 2 grams and 32 grams. So if I make ratio of them, like if I say the ratio of 16 into is to 32, then it's gonna be 1 is to 2, which is a simple whole number ratio, right? So what this law of multiple proportion say, which was introduced by John Dalton, is that when two elements combine, they form more than one compound, and if we make the ratio of these two compounds that are made by these two elements, then it will form a simple whole number ratio, right? So this 1 is to 2 is a simple whole number ratio. Next we have is how to find a molecular mass. It's about sum of atomic masses. For that you have to learn mass of one atom, like hydrogen has 1 U, oxygen 16 U, carbon 12 U, and Na means sodium is 23 U, Fe means iron is 56 U, calcium 44 U, and etc. etc. You have to learn the atomic masses of the elements and gases. Let's take an example. For example, I have to find the molecular mass of carbon dioxide. How I'm gonna do it? So here is only one atom of carbon. It has mass of 12 U, so it's gonna be 12 into 1 plus the next element I have is oxygen. The one atom of oxygen has atomic mass of 16 U, right? Or 16 gram. 16 gram means it is gram atomic mass. 16. And how many atoms of oxygen are there? There are two atoms. It's gonna be into two. Then you can just further do it, then it's gonna be 44U. So carbon dioxide has the molecular mass as 44U. Let's take a next compound, C6H12O6. It's glucose actually. So to find the molecular mass of it, I have six atoms of carbon plus two atoms of 12 atoms of oxygen actually, and then I have six atoms of oxygen, so it's gonna be 16 into 6. And when you just further solve it, you will be getting 180U, and this one is your answer. Easy. So this was all for today's class. You can see me at lecture number 2, which is all about mole concept. And also, yeah, one more thing, we are gonna solve a lot of numericals and mole concepts too. So it's not about understanding concepts, it's also about practicing questions as many as possible. Thank you for watching.